In my previous video, I've shown you the power transformer wizard, the free calculator on my new website, and I also shown you the paid version of the power transformer calculator. And today I would like to show you the single-ended and push-pull output transformer calculators from the paid bundle. So all three are included in this latest online version, and also the choke will be included slightly later, but there will be some other upgrades soon as well. And this is a one-time membership, so if you click here and you go to sign up now, after you sign up, you will get access to this new bundle. So once you do all that, you will be able to choose which of the calculators you would like to access. And so today I will show you quickly the single-ended output transformer. And as you can see, we have quite a lot of new options, and the wizard calculator is included in the audio transformers as well now. So it's a great tool to help you not guessing, but being more confident in choosing the right core size and type and bobbin size for your output transformer. So we also have the option to choose whether we want a hi-fi output transformer or guitar amp, and as you can see, it automatically gives sort of a starting point for both. Of course, you can modify all of the settings in this version. So let's start with the hi-fi. I'm building a Magnavox kind of inspired single-ended amplifier. It's a small 3-watt single-ended amplifier, but I want to make a really nice output transformer for it. So it's 3 watts, so we put 3. We can later manipulate these two values depending on the core and other things, but so let's check the primary plate load. So it's going to be around 5K. From the data sheet it says 5,200 ohms, and for single-ended operation the current is 0.48 milliamps, so we can go to 0.05. And as we can see, the wizard is calculating automatically. Now for the power transformers, it's set up for a pretty high stack fill, but in this case it's optimized to give you the correct starting point for the size of the transformer, and the stack fill is going to be very low, because usually when we have single-ended output transformers we use higher or bigger core size, and we use bigger than we would usually use for a guitar amp output transformers, and we usually use thicker wire than necessary for the currents, and we also use different interleaving patterns, which also require more space because you need more insulation between all the different windings. So usually around 40 to 50% of the normal stack fill would be recommended for single-ended and push-pull, so audio amplifiers or audio output transformers. And in this case, I will go with EI 66. I have also 68, which I think I'm going to go with. It's very similar in size. The center leg is the same, it just has slightly wider window. We have the option for 2.2 by 3 to this is 60, so it's slightly smaller, which would work just fine for 3 watts. But what I have is 2.2 2 by 2.5. So, and this is slightly different from the EI66, so it's 3.3 by 1.2, if I'm not mistaken. Okay, so we have our core, and then if we go over here, we can see with the most basic, core material, we would need quite a lot of windings in the primary, and I believe some of the old European and some of the jukebox and radio amplifiers use this kind of transformer with around 5,000 turns of a really thin wire. But since we are using larger core, and I will be using the higher quality core, so M6 quality, I think we can safely go to 6,000 GS Gauss. So this is going to reduce the number. So this would be a good number. I think with this number it would give us definitely a response up to 20 hertz. But yeah, so I guess it would be even safe to go to 30 hertz here to get around 2,800. I think this would work just fine. And it would give a nice balance between the low end and the high end. So yeah, something around this. So I would choose this size, and we can then choose the wire. I will use the same one as here, 0.15, and here I would go with 0.5. We could of course go with a higher one, 0.65, if we really want to lower the DC resistance. Here we could also go with 0.18. I think if we would go with 0.18, it would still be in a really low stack fill. Yeah, and we can also go with, so we can see that we have a really low DC resistance on the secondary, and we can see here pretty high DC resistance because of the many turns of thin wire. And the more you go, like if we would go to 0.2, we can see it's going even lower. So, but yeah, so whatever you have on hand with this way of calculating, which I believe is the correct way for audio output transformers, especially for hi-fi. This way you are getting, you have plenty of room, and you can choose whatever wire you have on hand. If it's higher than like 0.12, I think you can use whatever fits your stack fill. Of course, because of the interleaves, I would not go higher than 60, 70, 80%. But yeah, so as you can see, it calculates all the different things as previously in the power transformer. And now we can choose interleave option. With just one interleave, it would give you the description and the number. So you would have half a primary, and then secondary, and then half a primary. That would be a basic interleave, and it would improve the top end a little bit. But if you really want to extend the high end to go really like up to a 30 plus kilohertz range, you would go with this type, which is recommended for single-ended output transformers, and that's 3 primaries and 2 secondaries. interleave. You have yeah, 1/3 of a primary, then you have half a secondary, then you put a third primary, half a secondary, third primary, and as you can see, it's a nice, really nice configuration, and it gives quite a extensive high end. So it opens up the high frequency response really nicely, and it's not too fatiguing to to wind. You have practically 3 of the same windings, and for primary, so 2 of the same ones for the secondary, and I would recommend this for single-ended amplifiers, especially if I mean, this amplifier would work just fine even without interleave. So if you would just wind primary and then secondary, you would still get a really nice sound out of it, even with a smaller core. But going with a slightly larger core and doing all these interleaves really makes for a nice balanced output transformer, which gives a lot of low, well, like bottom end, and a lot of high end, so you don't lose or exaggerate anything in the output. Of course, providing that the amplifier is nicely done. And additionally, for single-ended, we have 2 options. One is universal secondary. So other than having a secondary here for 8 ohms or 4 ohms or whatever it is that you want to wind it for, you can also, by one click here, you can calculate the universal secondary for 4, 8, and 16 ohms, and it will give you all the winding data here. So you can make a continuous winding, which is not going to take too much space, and it's going to give you, so you would wind all 3 just with, you can go, in this case, since you have a lot of space, you can go with the single thickness of wire, not too complicated, and just pick the 0.65, let's say, or 0.6, and then wind the whole secondary with 0.65. And you can check if that can fit by putting 16 here and keeping the custom wire at 0.6, and you see that we are barely reaching 45%. So this is a great way to check in advance if you want to have universal. I usually don't do that. I usually wind just for 8 ohms usually, and but it's a nice feature and option to have in case you want to wind universal secondary. And for you can also choose, let's say if we would want to calculate a guitar amp. I'm just gonna reload the whole page. Yeah, one thing I forgot to mention is we also have the ultralinear mode, which will give you the so this would be the total number of turns, but here you would have the split plate turns and the screen turns. So you would have from center tap to screen, you would have 1136, and from screen to plate you would have 1705. So you can also select the tap at what percentage from the center tap you would like to have it, and yeah, so it's a really simple way of calculating and having all the options with just one click. And yeah, and if we would go with with a guitar amplifier, let's say we want to calculate output transformer for a Fender Champ, we'll go 5 watts, and we can change these of course later. We have for Champ we had 8K, I think, and the plate current is 0.035 if I remember correctly. Of course, you can change this to 4 or 8 ohms. I think originally it was 4, but whatever. And we can see that that it's recommending us the EI48. I think original was on EI42, the smaller one, but I wound it using this one and I had really good results. And it's easier to wind because you have more space and it's not that much bigger than the original. So and these ones can also be used for reverb output transformers for like a 6G 15. You can wind the same kind of same size you can use for it. It's a really good size to have on hand because many audio output transformers also use it, and you can use it for chokes. It's a really good size for many different purposes. Okay, so I would use 1.6 times 1.6. Let's say that's the basic one, and I forgot what the size. I think it's 2.4. Yeah, 2.4, 0.8. Okay, and of course this is for guitar amp. We can go even higher with the frequency, or we can move this to 10K, so whatever you prefer, but I think we can easily and safely go to 10,000 here, and yeah, even this we could raise for so yeah, something around this. I used to wind it around 2,800 if I remember correctly, with really great results. And with this kind of amplifier you cannot really go wrong. So yeah, of course no interleaves for Fender Champ. It's just primary and then secondary on the top of primary. Nothing special. Yeah. So all the same options even for guitar. Of course, if you want to have ultralinear universal secondaries, you can play with all of these settings and get all the wire gauges you have on hand and whatnot. So this is this would be the single-ended output transformer, and the push-pull is very similar. Practically everything is the same. You just have two windings instead of one. But let's say if I need to wind the Marshall style 50-watt guitar amplifier, and it's 3,500, and we have 100, let's say 100 milliamps. We can check what the wizard would suggest, and yeah, I would pick this one, 3.2 by 3.2. So good guess from the wizard. And window length 1.6, and you would get the number of turns and all the rest. As previously, we can play with different values. For Marshall, I think they do have interleaves, different interleaves. I think they use this style depending on the year and the amplifier, but this style is more for hi-fi, but some of the guitar amplifiers use it. It gives a balanced DC, and so it's Fender usually uses this one just half primary, secondary, half primary, but this one is more like of a hi-fi sound, and it's quarter primary, half secondary, half primary, half secondary, and quarter primary. And this way, when you have a really balanced DC, and you have a really nice interleave pattern, which gives also really high frequency response, which is really balanced. But for Fender amplifiers, I would not recommend it because it doesn't really give that warm sound that we are used to with Fender amplifiers. It's more for the Marshall style amps and higher wattage amps, I guess, higher than 30 watts, let's say. But you can, of course, experiment. You can also put ultralinear mode and universal secondary, as I mentioned, and yeah. So yeah, I guess it's very similar in everything other than the interleave and some of the details, but all the rest of the functions, including the wizard, are optimized for push-pull, and you can choose for equally for hi-fi or guitar amplifier. And I think it's a really quick and useful tool for calculating it. So check out my new web page, and if you're interested, you can subscribe for the paid subscription, which is actually a one-time membership. And if you have any questions, write in the comment section below, and I'll be glad to answer it. Thanks for watching.